and I will stop time to time and ask if you have any questions. But as you know, it's an online lecture, so it will not be so interactive as what we have in the class. Some of you may like it that I will not be, interacting with you. But again, so I would appreciate if you have your questions and if you let me know if you are getting it or not. And at the end of the lecture, I will ask you to raise your hands. I will call out your names and ask you to raise your hands. Okay, so don't sleep. Okay, so this is how it's going to be. So pay attention during the lecture and be there till the end so I can mark your attendance. Okay, so in this lecture, we will be going through the measurement of substructures. So already started with the measurement of steel and with the dimension sheet. So in this lecture, you will see that how we can use the same concepts for measurements of substructures. The sections of NRM, which we will be discussing through these slides, are these. Okay, so they are related to excavation and groundwork, some concreting, masonry, ground remediation or soil stabilization. So the last one is only applied where it is required. The last segment, the last activity in the project is not applied on all projects. It's only applied where it is required. And why it would be required? It would be required if you feel the natural ground and soil does not have enough strength which you require for your structure. Okay, so then you may go for ground remediation or soil stabilization, meaning is strengthening the natural ground. The last one basically means is strengthening the natural ground. Okay, so first of all, let us define what we mean by substructures. So a substructure is a general term, generic means general term, which is used to describe any construction work, any construction operation which happens below the ground level, or I would say till the ground level. And the most obvious one of that is foundations. So they are often referred to as foundation work as well. So substructure is often referred to foundation, but it has, as you can see, there's a list here. It will involve many other items in addition to foundation. For example, excavation, disposal, and filling. So excavation, okay, we dig, and then you have to dispose of that material. And as I mentioned in one of my earlier lectures, that once you dispose or once you are done with your construction work, you cannot just leave the excavated land as it is. You need to fill it and make it solid. Okay, so filling is another activity involved here. Then we have foundations, which are mainly made up of concrete. Then we have construction work of blockwork or brickwork to support the external walls. Because for the internal walls, then they are supported by ground beams. Okay, so the internal walls may not have the beams because they are already on the slab. They are not on the edges. So the main problem is at the edges we can have external walls. So the brickwork or blockwork up to the ground level. Again, we are talking about substructure. So your walls may go up to any height, but here we are talking about brickwork or blockwork up to the height of the ground level or the floor level. Now, what's the difference between brickwork and blockwork? It's the type of block you are using. Both of them are blocks basically, but block is made up of concrete. When we say blockwork, it means it is made up of concrete, and brick is made up of clay. It's a type of soil. Okay, so you take the soil and you put it in the mold. Okay, not any soil, it's a specific type of soil, and then you put it in the oven. Okay, and you heat it and it becomes a brick. So if you search online for bricks, you will find these are the red ones. If you have seen it in movies and They are used in many countries, in Pakistan, in UK, in US. They're used in many countries, but here I've not seen it. But they are very good in terms of absorbing the heat and maintaining the temperature. But for some reason, obviously the reason is we don't have that type of soil here. The brickwork requires natural material to make the bricks, which we don't have available in the GCC countries. But they are very good in terms of maintaining temperatures. So that's why they are used in many countries, so they can save energy and so on. But we have the blockworks. Okay. Then we have the floor slab. Okay, the first slab, which is at the ground level, not the top one, the one which is under your feet. Okay. Then we have the damp-proof course and the membrane. Okay, I will show you examples of each one of them. But this item deals with stopping water seeping from the ground to your structure. This particular item is used for stopping the seepage of water from the ground into your structure. So the ground may have water, okay, and the water under the ground level does not remain the same. There's rain somewhere, there's a water body somewhere, and any changes which happen because of these things can increase or decrease the ground water level. Okay, so because of these changes, there may be some water seeping through the structure, which is obviously damaging. It will corrode the steel, it will damage the concrete, and so on and so forth. And obviously, even in the floors, it may cause swelling. You may have seen, especially in walls, if you have any pipeline leaking through the wall, you will see that it is swelling. It is becoming bigger, and the paint is coming off, and so on and so forth. And so these are the common items, and then you can have other additional elements which must be shown in the design, meaning the drawings and specifications. So the measurement workflow passes through these stages. The first thing, which I mentioned at the end of last slide, that you need to look at the drawings and specifications. Okay, and these drawing and specifications should tell you about the existing ground level, the reduced level which you want to achieve for your construction work, and the foundation levels. So there's an existing ground level without doing anything. Then you want to clean it and level it to get to a constant level, that is a reduced level. And then you want to do some excavation to reach up to the foundation level. So all this information will come from the drawings and specifications and other things as well. Obviously, they have just mentioned these, but there are other things, the size of the foundation, the reinforcement, and the size of the walls and everything. Okay. Then you measure the topsoil. Okay, topsoil removal basically. So the topsoil is usually weak. It usually has a lot of grass and unwanted items. So you want to get rid of it. The soil which is slightly under the topsoil is usually the one which is more useful, and it can be used for construction work. So normally the topsoil is removed, especially on plots where you don't have anything right now. So they're empty plots. So you must have seen when there's empty plot, the topsoil it may have water on it, it may have grass on it. So these things are not required for construction. So you remove it. Then you calculate the center line we discussed in the previous lectures, and the internal girthing, the external girthing. Okay, and the center line calculation is done, and then you will use it, as you will see later on in these slides. We'll use a center line for doing many things, for calculating many items. Then you measure the excavation. Okay, excavation, it could be foundation, isolated foundation, or it could be trench foundation. Okay, so trench is a continuous foundation under all walls, and isolated foundations are for columns, which are only under the columns. And we have done both of them in the previous lectures. Then you measure the concrete. It could be for foundation, it could be for ground beams, and so on and so forth. And you measure the block work, which is the amount of wall which you have under the ground level. Okay. One thing which is not mentioned here is dam proofing, but that is also required. Okay, and concrete could also be for the floor slab. Okay, so it's just giving you some steps. Obviously, the details will come later on. So once you have done this, you can start making your BOQ. And the important thing about the BOQ is you need the description of all these items. So this will require you to go to NRM2 and find out the description. Okay. I hope everything is clear up till now. We're just going through the definition and concepts right now. Okay. So we start with the first item, which is the excavation and filling. And this you will see in these slides, the section numbers are mentioned. They are the NRM2 sections. So you can go back and check the description of excavation and filling from section 5 of NRM. So when you are booking the dimensions of excavation, then you need to take into account the removal of the topsoil, as I already mentioned. This is usually undesirable, and we have to dispose it off somewhere because it's not usable. So usually we get rid of it. Then you have the bulk excavation. So bulk excavation is usually slightly deeper. And as I said, it is to maintain a particular reduced level which will become your reference for the whole construction work. Okay, so you will say that my footing is 1 meter under this level. Which level? Not the natural ground level, but the reduced level which you will attain after doing bulk excavation. Okay, so there is topsoil, you remove it. This is called cleaning. Okay, this is just for the sake of cleaning. Then the work comes for leveling the ground. The real leveling of the ground is here when you do the bulk excavation. Okay, and here you try to maintain a constant level across the plot. So the whole plot should have a constant level or the gradient in case of road works. Then we don't prefer to a constant level. We prefer a constant gradient. But in any case, after doing the bulk excavation, you will have the ground at the required elevation, and that required elevation becomes your reference. When I say excavation 1 meter under the existing level, this is the level after bulk excavation, and so on and so forth. Okay, and then you have the foundation excavation. Okay, so this is now done for the beams and columns. Okay, so we have two types of excavations here. For the removal of topsoil, for achieving the reduced level, and then the last one is to get to required depth for our structural work. Okay, so the first two are just preparation. Each one of them, you see the disposal here. Okay, and later on you will see the disposal may not be always to another site. Okay, so these things will become the headings of your dimension sheets. Okay, and then you will refer to the particular section in the NRM. And when you are making the BOQ, this will again be treated as a separate section. So excavation and filling will become a separate section. Under that, you will have topsoil, bulk excavation, foundation excavation, and so on and so forth. And here you can see, I believe the clauses are correct. Okay, I believe the clauses are correct. Maybe there's a difference between these numbers, the last numbers. There are two NRM2s. I don't know if I mentioned it earlier or not. If you search online, you will find two versions of NRM2. One is the old one, the other one is a new one, which I uploaded. Okay, the new one is uploaded. The difference between them is the main difference is between them is representation of the items. So this is what you will normally see in the old NRM2. Both of them are the same addition, but they change the arrangement. Okay, but the section numbers are, I believe, is still there. As I said, in the new or the old one, this is still section 5. Okay, so it's the same. Okay, and obviously the units of measurements have not changed. Excavation is measured in cubic meters. Disposal is also measured in cubic meters in all cases. So there is no change here. Okay, so before we start the measurement, we need to study the survey drawings. Okay, the survey which is done at the site, which will give you the reduced level, the existing level, and so on and so forth. And any the specification which are included with the drawings must be gathered. And you may need to study the borehole log details to find out these things. Okay, what is a borehole log? It's basically a sample of the soil which you take by digging into it. So it's not the actual excavation. It's a very small hole which is done like with a drill. You have seen the drill machine which you use for drilling in the wall. So it's like slightly bigger, and you drill it in the ground, and it will give you, or it will extract the soil sample from it. Okay, it's called as borehole. Okay, borehole. So it's very common in Bahrain as well as other countries. In Pakistan, we use it for even getting to the groundwater level as well. Okay, so they use it in houses as well. But anyways, it's like a small drill or big drill machine, not a small one. A big drill machine, you use it to extract soil sample from some depth. Okay, so it's not like you are taking from the top. You are going maybe 1 meter, 2 meter deep and then extracting the soil sample. And this soil sample can tell you about the existing ground level, uh, the excavation level, what is the level of the soil at the excavation level. You have not done the excavation yet, but you are taking the soil from maybe 2-3 meters deep. And it will help you to find out not the borehole, okay, the everything, the survey drawing and everything. And with the borehole, it will help you find out the existing ground level, the excavation level, and the finished floor level and the foundation level depth and width. Okay, so existing ground level is a natural. Excavation level is where you want to reach after you do the excavation, and finished floor level where you want to have after you finish the construction. So this one is natural, existing. This one after doing the excavation. This one after finishing the construction. Okay. So you study this information, so you have these three things mainly. Okay. So this is the drawing which will explain a lot. Okay, so pay attention. And we will be just playing around this one. Okay, this is our main sample for template. Okay, so this is your excavation level. Okay, the last one, excavation level. Over the excavation level, you have something which is called as blinding. Blinding is a type of weak concrete. If you go back to previous slides, you will see where I have shown the drawing of the footing or the foundation. Under it, you will see something like this, a blinding or something. Okay, like a small strip, a small rectangle. So it is made up of weak concrete, weaker than the foundation, and it does not have reinforcement. The main idea here is to protect the main foundation from water, from any cracking. So sometimes under the foundation, there could be settlement as well. Like one side of the ground may be sinking or going down, the other one is going up, something like this. Mainly happens because of the changes in water level. So we want to protect the foundation and the structure itself by providing this blinding. Okay, so it's a sort of weak concrete, which is for the protection of the main footing. And then you have the foundation. Okay, so at the excavation level, then you have the blinding, then the foundation, you reach the foundation level. Okay, and over the foundation level, you have the reduced level. So before you started any structural work, you leveled the entire ground to this one, this value. Okay, the reduced level. And this is the top level of the foundation, so nothing. So in some cases, so wherever the reduced level is, this is where you will put your slab and do everything. So this must be hardcore. Hardcore meaning it must be solid. It's not loose. It's fully compacted. Okay, and if possible, we will try to make it with good material of good strength. Fill it with material of good strength if possible. Okay, so this is the reduced level after which you or at which you or the level which you consider as the reference of all your construction work. Okay, then you have this sort of insulation. Okay, like I said, to protect the structure from whatever level. Okay, then you have the concrete of the ground slab. Okay, after the ground slab, over the slab you put something which is called as screed, and it is mainly for and we use it over the roof as well. Screed is used over the roof as well. Okay, and the main idea is to again to protect the slab and to maintain the temperature. To protect and maintain the temperature. Okay, so we have this screed, and over the screed you have the finishing. Here it is mentioned tiles, but you know finishing can be anything. Okay, finishing can be of tiles, it can be of mosaic or whatever. I don't know what are the materials used here, but it can be a marble or tiles or whatever. Okay, so you have the excavation level, then the blinding, the weak concrete foundation, then the compacted earth up to the required reduced level. Then you have insulation, then you have the slab, then you have the screed to protect and maintain temperature, and then you have the finishing. Okay, and this was the main ground level. So this one and this one. Okay, usually reduced level is low, ground level is existing ground level is high. Okay, but it can be anything. You may decide that no, my reference level will be higher than the ground existing ground level, existing level. Okay, so it can happen in this way as well. And obviously the existing level may not be plane. It may not be straight. So it may happen at some locations it is higher, some location it is lower than your reference level. Okay, so it's possible. So now you can see here they're using the term ground level and ground slab. They are using it for the building itself. Okay, so I have used it in the previous slides or in my previous talk as the ground level. So they are saying when I was saying ground level, I mean the existing ground. Okay, but here they are using the term ground level and ground slab as the slab and the level of the structure. Okay, of the floor. Okay, the floor after the construction. Okay, so keep it in mind. So ground slab means the concrete slab which you will have under the first floor, and then the level of the top of that slab is the ground level. And then you have the existing level, which is the normal natural soil before doing anything, before any construction or anything. Okay, so these are the items, okay, in terms of levels. Okay, if you have any question at this stage, please let me know. Any questions, any queries, any confusion? Should I move on? Okay, move on. Very good. Okay, so we'll move on to the first item, which is removal of topsoil. So this is the type of topsoil we are talking about. You can see grass and so on. Obviously, you would only dream of this type in Bahrain, but it can be any type of grass or any type of vegetation. It's not required basically. The vegetation or the grass is not required. Okay, we cannot build our structure on top of this type of soil, even if the grass is very little. Okay, it doesn't look so green as this one. We don't want it. Okay, because the grass means water. Okay, and the grass will grow as well, and the grass may have some other elements which may interact with the water which you are putting in the structure, and it will grow, so it may cause some cracks, and obviously it will hinder the construction work as well. It will obstruct it, so we don't want it, so it will be removed. Any soil with vegetation, grass, trees, it must be removed. If you go in NRM2, you will see within the same section, the removal of trees and other these sort of items. Okay, so we don't want them. Okay, like we want them, but not under our structure. Okay, so it should be removed. And yeah, it can happen that later on you may use the soil for filling, not the grass, obviously, but even the grass becomes dead. Okay, once you remove it and then you store it somewhere and then you use it some later on for filling, you can do it because the grass obviously becomes dead. So using natural soil or the excavated soil for filling is something which is good for us. It will save cost. Okay, because you don't have to buy the soil, you don't have to transport this soil for disposal, and you don't have to bring the new soil from somewhere else. So a lot of transportation is saved, a lot of effort is saved, and you expect that there will be a small variation in the soil properties because you are putting the same soil which you have removed. So this is good. Okay. Any further excavation would be measured from under the topsoil removal, not over. Okay. Over is what we will remove. So after removal of topsoil, any excavation will be measured from that point downwards. Okay, and the topsoil is usually measured in square meters. How many square meters of topsoil? Square meters meaning the area of the plot, basically. Simple. Okay, square meters, area of the plot. Okay, with the average topsoil depth is mentioned in the description. Okay, so we are trying to find out the area because the depth is usually mentioned in the description. Okay, so we are not saying that we will keep it in square meters, but we are saying that uh, the the thickness will be mentioned with the description. So you can multiply and then later on get in cubic meters. So this is the section from NRM2 for topsoil removal. Okay, so if you find this one and go up and down, you will find that items of removal of trees and so on and so forth. Okay, so you can see it is part of site preparation measured in square meters, and the depth must be stated. Okay, and there are no other levels here. Okay, in some cases now you can see here, you may be, this is when you have open field. So there was nothing earlier. What they are calling here as a green field. Okay, so there's open plot and vegetation, that's it. But in some cases, you may be doing construction which already has a hard ground. So you can see another item here, removal of hard surface. Okay, removal of specific items. So it depends upon what is the existing condition of your plot. Okay, then we have the bulk excavation. Once the topsoil is removed, then you do the bulk excavation, which is also called as a reduced level excavation, and it is measured excavation measured in cubic meters. Okay, so it's very obvious. Okay, we have used it earlier as well. So it will, after the bulk excavation, it will state the maximum depth which is required to get the reduced level. The description of bulk excavation should mention the maximum depth which you require to get the reduced level. Because now you can see here, for example, this is my ground. Now you can see this ground is not level. Even if I remove this soil of excavated, this ground is not completely level. So, and I want this reduced level. Okay. So at some points, the difference between this one and this one can be 1 meter. At some other points, it can be 1.2 meters. At some other points, maybe 0.8 meters. Okay, so the description of this item will mainly deal with the maximum depth. Okay, they put the maximum depth. Okay, and this is based upon the reason that usually after you remove the topsoil, there will not be much variation in the level you achieve after that. Okay, so if you measure the, or if you mention the maximum difference between the required reduced level and the existing one, then it is on the safe side. Okay, but if you feel that the variation is very high, at some point the difference is only 1 meter, at some other point is 5 meters. You cannot ignore it now. So in that case, you may go with average. The old NRM2 was working on the concept of average. The new one says that you have to take the maximum. Okay, but Obviously, it depends upon the site conditions, the site level. If it's too much slope on the site, so there will be a lot of variation. Then you cannot rely on the maximum. Okay, but the regular standard is the maximum difference between the required reduced level and the existing reduced level must be used in the description. Okay. And this is the item from the NRM2 bulk excavation, and it should not exceed more than 2 meters. Okay, it could be between 2 meters and 4 meters. It could be more than 2 meters. So, like this will come in the description. Okay, like you have seen, we have done for the foundations. Okay, so bulk excavation, you will mention in the description bulk excavation, including this whole thing. Okay, or this whole thing, whatever applies. And then you will mention the limit of the level. Is it up to 2 meters? Is it between 2 meters and 4 meters? Is it more than 2 meters? More than 4 meters, more than 6 meters, more than 8 meters. So this is what they mean. Okay, so they are after in stages of 2 meters, meaning after 4 meters, you will see, is it exceeding 6 meters? Then you will mention bulk excavation, blah, 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 exceeding 6 meters. Is it exceeding 8 meters? Then you will say, okay, blah, 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 excavation and exceeding 10 meters. So you will mention the closest lower 2 meter interval, closest lower 2 meter interval. Okay, in the description. And from where you will get these dimensions, you will get them from the plan. Okay, and obviously the levels must be given by the contractor or the surveyor. Okay, and here you can use basically it is done till the extent or projection of the footing of the external wall or the column. The removal of topsoil and bulk excavation, both of them are done till the projection of external footing or foundation. Okay, so for example, let's say this is your plot on this side. Okay, this is the plot, this one. Okay, you can see they have given the internal dimension. Now we will use it later on. Okay, so keep this in mind. One internal dimension is 4,500 millimeters. The other one is 9,000 millimeters. So 4.5 meters, 9 meters. Okay. Now, when I will do my construction involves the walls, right? So I have to include the walls. My construction involves the footing as well. Now, the footings which are inside the plot, they are no problem. They are already included. When I take the plot size, they are already included. The footings which are outside or which are at the edge, not the outside, okay, which are at the edge. So this footing, let's say this is the footing, this one is the footing under this wall or a column which is, in line of this wall. Okay, so this, as you can see, this footing does not end at the wall. The footing extends beyond the wall. Okay, so my removal of topsoil and my bulk excavation should be up to the edge of the footing, not the edge of the wall. Okay, is this point clear? The groundwork is done till the edge of the last footing, not the edge of the external wall. Okay, because my structure is up to the footing. I cannot leave it. Okay, because I still have to do this excavation. I still need this ground to be solid. I still need this ground to be strong. Okay, and I still need the levels to be maintained so I can do the excavation for my external footing. So in all sides, we will see how much far from the wall the footing is going outside. And I will calculate these items, topsoil and bulk excavation, up to that point. Okay, so is this point clear? And you have to mention it like we have seen in the previous lectures, and you have done it as well. You have to show it in the waste calculation on your dimension paper. Okay, so I hope this is clear. No, like I said, it could be grass. Okay. And by the way, I don't see, I have to change my screen to see your chat. So if you can speak up, it will be better. At least raise your hand so I can see the notification. Okay, so I'm looking at the presentation and I don't see the message. Okay, so the question is that is it only done for grass, the topsoil removal? Mainly for grass, mainly for grass. Okay, if there is no vegetation, you can directly start with the bulk excavation. If there is no, if you feel the topsoil does not have any elements which may damage your structure, grass, vegetation, trees, these are things which can damage your structure. Okay, so this is like a call which the engineer has to make, that should I uh, do the topsoil removal or not. But if it is grass and vegetation, definitely, for sure, you will do the topsoil removal. But otherwise, you will you have to decide. And if you're asking for section 5 has everything. Okay, yeah. If chemical, obviously, we are not sure if now the environmental standards are very high, so nobody will leave chemical on the soil. Okay, so don't worry about that. You will, if you see that, you report it. Okay, you don't excavate it. Okay, you will report it. They will come and check why why there was chemical on the soil. Okay, who dumped it there? Okay, there. So it's protected. Okay, but I'm talking about natural things which can damage the structure, like grass and vegetation and trees and maybe asphalts, let's say. Okay, so somebody had a parking area somewhere and they were using asphalt, and you know the asphalt, uh, it under the temperature and with water it can react. Not with water, but temperature it can do something. Okay, so these type of things you need to keep an eye out. Okay, and section 5 includes all excavation filling items, topsoil, bulk excavation, footing excavation. We have used it earlier. Okay, so section 5 includes all type of excavation and these things. Okay, so should I move on? Okay, I take the silence as yes. Okay, so the point was that you need to uh, take it up to the end of the foundation, not the end of the wall. And the foundation can be beyond the wall. You can see this area. So this is my foundation. This is my wall. Okay, the wall must be bigger than the foundation to bear the column. Okay, so that's why. Let's see now. Yeah, so I have this now example here. This is for topsoil excavation. And what you are looking at on the right hand side is the waste calculation which you are doing for the dimensions. Okay, the real calculation is here. This is the real calculation. This is showing, this side is showing how did I get 18.51 and 15.51. So the item is topsoil excavation. The item is topsoil excavation. This you will take from NRM2 and you will add your dimensions. So like they have. You can see now it was mentioned in NRM2 that the depth should be mentioned in the description. So depth is mentioned, okay, that the topsoil will be removed. The top 150 millimeters of the topsoil will be removed. Okay, this is how they do it. So in some cases 200 millimeters, some cases 150 millimeters. Okay, very rarely 100 millimeters. So less than 150 is very rare. Okay, but in any case. So this is my main. Okay, I'm looking for this one. But to get to this one, I need some waste calculation. Okay, so this is how they are doing it. Okay, so now we go here. Okay, now what they are saying is this thing is 750 millimeters. Okay, this thing is total 750 millimeters. Okay, from one end to the other end. Okay, and I want to do it up to here. I have internal dimensions, so I have internal up to the face of the wall up to here. Okay, this 9,000 and 4,500 is up to here. Let me make it. Okay, So the red lines are just showing where it should be, but the dimensions are given for the black arrows. Okay, so that you can see it's internal wall to internal wall. Okay, and internal wall to internal wall. Okay, so I'm here, and I have to get from here to here. Okay, I have to get from this point up to this point. This is the end of my excavation and topsoil removal. Okay, so foundation width is total 750 millimeters. Okay, 750 total foundation. Then I have a wall of 343 millimeters here. Okay, so 750 minus 343. Okay, because I want to calculate this projection. How much far from the wall I have to go? How much ahead of the wall I have to go? So I want to calculate this one. So total was 750. From there, I subtracted 343. So I have the 2x. Okay, the extra, it will damage the drawing. Okay, so I will have the 2x. So from 750, if I subtract 343, I will have the remaining this side plus this side. Okay, and I only want it from one side. Okay, so 750 total minus the wall 407. 407 includes this x and this x both. But I only want this one. I only want to add this one because this one is already in on the inside. Okay, so I don't need to add it. It's already included in the internal dimension. Okay, so what we will do is we will add this one. Okay, so how do I get this one? 750 minus the wall has this plus this. So I divide it by 2. So you can see 750 minus 343, 407. I divide by 2. And you can see how it is divided by 2. It's same what you use in your school. Okay, 2 and curve and 407. So this is the division symbol in the dimension sheet, the dimension paper. Okay, so it's nothing new here. So this is the projection of footing after the wall. The projection of footing after the wall. Okay, so I had to do till the wall plus 203.5 on each side. Okay, till the wall plus this much on each side. So this calculation is done for this plan. Okay, so they have given me external dimensions now. Keep in mind, this plan is not same as this one. They are two different. Okay, we will use this one in some other slides. Right now, focus on this one. Okay, only focus on this one. Okay, so 18 meters external dimension on this side, 15 meters external dimension on this side, external. So I'm already at the end of the wall here. I'm already here. Okay, so then I will only add this one, but it should be done on each side. It should be done on each side. So 18 meters, this one, plus the projection of the footing on each side. Okay, how much was the projection? 203.5. So on each side, so two sides. So two sides added with 18 meters, two sides added with 15 meters. So this is your perimeter now. This is the girth. Okay, and so if you want to calculate the area, then you will multiply it. It's not given here. So the final step will be this multiplied by this, and then you will get the area of soil removal, topsoil removal, and you will multiply with 150 millimeters to get the volume. Okay. So are there any questions from this calculation? So we are focusing on this plan. External dimensions are given. I wanted to have the projection of the footing outside the wall. So then I cut a section here. You can see the section. This is my footing, 750 millimeters. Wall is 343. I subtract 343 from 750. I get the projection on both sides. Divide by 2. So I get the projection on one side. Okay. And then this projection is added to the length, external length of each side. So 2 times added here, 2 times added here. So one dimension, second dimension. You multiply, you will get the area, and this will be multiplied by the depth mentioned here to get the volume. So is there any question, any problem here? Clear? Okay.
Yes.
Okay. So moving on, we have the foundation excavation then. Okay. So you can see the NRM sections are mentioned here. It's easier for you to go and check. So foundation can be in the form of trenches or pits, or it can be something else. There are many types of foundation. This is not the course where you learn about the types of foundations, but you can see, for example, when I say trench, this is a trench foundation. You can see it goes under the entire wall. So this is one wall, this is another wall, this is another wall. Okay. So this will continue like this. So this is like a trench foundation. Okay. So trench foundation is very common. Okay. The other type of foundation we use is called pit foundation, or it's not the type of foundation, it's a foundation excavation, type of foundation excavation. Okay. You can have trenches or pits. Trenches means it's a very long, narrow excavation. Trench means long, narrow excavation. So this is done when the foundation is under the entire wall. Okay. And pit is like a rectangle or square, could be a circle as well, obviously, but it's a hole. Okay, it's a hole which could be square, circle, or rectangle. Okay, so the figure at the bottom gives you the pit foundation. So this is the pit foundation. So this is like the trench. Okay, it's narrow, long, and this one is a pit. Okay, and the level must be stated in the description. The level of foundation must be stated in the description. And excavation, as we have seen, is always measured in cubic meters. And this is the NRM section, which will help you to describe it. You can see the units are in cubic meters. Excavation starting level is stated, if not the original ground level. Okay, so original ground level, whatever the ground level is. But as I mentioned, then we do bulk excavation to get to the original level. So one more thing which I forgot to mention, in this case, the topsoil and the bulk excavation. Remember, bulk excavation is done to get to the reduced level, required reduced level. Okay. So topsoil removal and then to get to this level. In both the cases, the area remains the same. The area remains the same. So that's why we did not calculate it again. Okay. So you can like put it one more time here for bulk excavation as well. But obviously the height will change. The height will change. The area remains the same. Okay. So this thing which you calculated can be used for topsoil excavation as well as bulk excavation. Okay, foundation, then coming back to foundation. Okay, so you can see it is under the bulk excavation, the excavation done for anything. So we have two items here. I showed you this one last in the previous slides, and this one is for foundations. Okay, so only one level is here. There's no, you don't have to mention the depth, but you have to mention the level. Okay, so it's not like this one. And this one you have to mention the depth, but here just mention the level. That's it. Whether the level is after 4 meters or 6 meters doesn't matter. Just mention the level. Okay. With all excavations, so we have mentioned 3 excavations. Keep in mind, we have mentioned 3 excavations. Topsoil is sort of an excavation. We call it removal, but you know it's a type of an excavation. So bulk excavation and then foundation excavation. All 3 of them, they need disposal of the material. Okay. We don't need to mention from where the material came from. Like you can mix the entire excavated material. Okay, like you don't need to keep the material of topsoil and bulk excavation and foundation excavation separate. After excavation, you can just put them in one truck and dispose them if you want to. In many cases, the disposal of material may take more cost than the excavation. Okay, especially for small building projects. And if these buildings are within the urban areas, so you don't have a land to dispose the material. So excavation, for small villas and building, the excavation is not so much. It's not so deep and it's not so big. So it's very cheap. Excavation is very cheap. But the material, if you want to dispose it of, there's no place. So if you have to dispose it of somewhere else, it could be after 10 kilometers, 15 kilometers. You have to bring the truck and they will load the material, they will take it there. And even then, for your information, you cannot dispose the material wherever you want, however you want. Okay, so it's not like, okay, this place is empty, just dump the material over here. It doesn't work like this. Okay, especially construction material which is coming in trucks. Okay, I'm not talking about a uh, small bag. Okay, so it could be more than one truck. So wherever you are disposing, you need approvals for that, and you may not be able to dispose all type of material. They may say no, this type of material cannot be disposed here. Okay, because we have some environmental issues or something. So you can combine the entire material and you have to look at the cost of the disposing. Okay. So that's why, because the cost is high, you need to mention it as a separate item. Okay. So if you go to NRM, you will find separate item for disposal of material. So you cannot combine excavation with disposal. Excavation is a separate item, disposal is a separate item, but these two are combined, like they are linked with each other. When you do excavation, disposal is required, obviously, but the cost is not combined. The cost is separate because disposal can take more cost or more money than the excavation itself. So you cannot combine the cost. Okay. So there are multiple options given in NRM2 to dispose the material as well, where you can dispose it off. The options are given. If you are looking to dispose the material off-site, somewhere out of your plot, not on your plot. On your plot is easy. Okay, it's allowed. It's allowed and easy. But if you are going to dispose it off somewhere else, then you need to identify the destination, and you have to check if there are any hazardous materials, as Abdulaziz was saying, any chemicals. Like, yeah, it's very rare that you will have such chemicals, but uh, the government will take all the actions, obviously. Even if it is not, the chemicals are not there, you have to prove it that it's safe. The material disposal is safe. Okay, so like I said, you need permissions and you need testing and so on. After that, you can dispose the material. So it's not easy. Okay, but you can see the options in NRM2, the options for disposing the material, but on-site is the best case. On-site disposal is the best case. You use the material on the same site. This is the best case. Okay, so you have this thing here. Okay, disposal. Disposal of groundwater is mentioned. This is again, there are some sites where the groundwater is so high, groundwater level is so high, then when you do the excavation, the water will start coming from the sites into your excavation. And it comes at very high pressure. There are some sites like this in Bahrain as well. Okay. So they have been cases where they did the excavation and they hit a water body, and obviously you are doing the excavation, right? So it's just a hole. Initially, just a hole. So the pressure of the water was so much that it came out of the ground and went up meters. Like it was like a water fountain. Okay, it has happened in Bahrain. Okay, so there are underwater bodies. We call them aquifers. You may hear about them in the other courses, the water courses, but there are aquifers in Bahrain which have so much water that if you crack them, okay, the water can completely, it will become like a swimming pool. Your excavation will become like a swimming pool. Okay, and the water pressure is also very high. You cannot contain it. Like you have to wait, close the work, and wait. So this is the disposal of groundwater they are talking about. Okay, and it could be polluted as well. Obviously, we don't know. And then this is the thing which we are talking about. Okay, the disposal of material. Okay, not the water or the material. Okay, and it's in cubic meters because excavation is cubic meters, so we already have it. And the destination should be mentioned. Okay, you can leave it to the contractor as well if you want. Okay, and you have enough size, you trust him, and you don't have any previous issues with the contractor. Your record is clean and his record is clean. You can, okay, dispose of wherever you want. If there are any hazardous materials, you should mention them and so on. Okay, and notes, as I already mentioned, we don't need to mention the source of the material coming from which type of excavation. Okay, so for example, we have a bay size, bay meaning a plot. Okay, plot level, a plot size of 30 by 30 meters, outer to outer edge of the foundation, outer to outer edge of the foundation, not the wall and not the plot. As I already mentioned, the foundation goes under the wall and it can extend beyond the plot area. So this is the total, okay, up to the foundation. Okay, so here the existing ground level is 19 point something something. Okay, from that one, they remove the topsoil. So you can see the waste calculation here. Okay, focus on the waste calculation here. Okay, or let us start from here. Okay, fine, no problem. Let's start from here. So for site preparation, they are doing topsoil removal. Topsoil must be removed from the top 150 millimeters. Okay, so the size of the bay, which includes the foundation, so no work required. They already did everything for us, is 30 by 30. And this 30 by 30 will be multiplied by 0.15, the depth, to get the topsoil which is excavated. Okay. One thing which you can see here, the topsoil when it is excavated, it will not be removed immediately from the site. Topsoil or any excavation, when it is being done, your labor is busy with that, and you may have trucks which are doing something else. And obviously, if the trucks are available, you will not waste your time in some other activity until you are done with the excavation. Okay, so now you are doing the excavation, so you are taking out the soil. Now you have to put it somewhere. Okay, so there are standards and procedures which you have to follow to store this soil before you dispose it off. Okay, so the excavated soil cannot be just left on the site in an unplanned manner. You have to take care that this soil is stored in a stable manner. Okay, otherwise, you put it on the side of the excavation, and because of something, it it falls into your hole again. So you do the excavation, and it's back into the excavation. So obviously, it will mess up everything. So you can see that they have mentioned when you remove the soil, it must be put on the sides in for height up to 30 meters. More than 30 meters, they feel that it will fall. Okay, so we have to keep it in a stable manner. So we don't make big mountains out of it. Okay, small piles, small heaps. Okay, small bunches. Okay, so this is the topsoil removal. Okay, this is a topsoil removal. Now, the existing ground level is this much is given. So they did the survey and they found the existing ground level is this much. From this ground level already, and obviously it could be an average value. As I already mentioned that if the ground is almost level, you can take an average value, no problem. So from this existing level, I already subtracted the topsoil. Topsoil is removed. So now the ground level will go from 19.49 minus the topsoil up to 19.34. So this is now the ground level after the topsoil removal. After the topsoil removal. Okay. The required reduced level, which they want to keep as a reference, is 18. So after the topsoil removal, it was 19.347. And after the reduced level which you need before you start any construction work is 18. So now you have to do bulk excavation now. Okay. So after topsoil removal, you will do bulk excavation. Bulk excavation should reduce the ground level from 19.347 to 18. Okay. If you want, you can keep the slides open with you so you can zoom in and zoom out. If I do it, the arrows and everything will mess up. Okay. Or just trust me if you want. Okay. Anyways, so after topsoil removal, this level, we require this level. The difference between them is the height of the excavation. Okay. And as I mentioned, now it should be the maximum one now. The difference will be taken where at the point where it is maximum. Okay. So 1.347. Okay. From the ground level after the topsoil to the required reduced level. So this is the height for which I want to do bulk excavation. So area will remain the same. I told you earlier in the previous slide, in the previous example, that the area for topsoil removal and bulk excavation is the same. You can see it's the same because already up to the outer edge of the footing. And then you multiply with the height. Okay, and this is the description again as is mentioned in NRM2 that you have to mention the depth if it is exceeding 2 meters, exceeding 4 meters, exceeding 6 meters, and so on and so forth. So you have to mention, so it's mentioned here. Okay. So this is the excavation. Okay. And then this is the disposal of material. Okay. You can add this one plus this one. In this example, they not add for any reason. I don't know. The type of soil is different or something, but you can add them. You can add them, no problem. Okay. If there's no much, like if you don't have any different plans, like the topsoil, I will use somewhere else or dispose somewhere else. And this one I'll dispose somewhere else. If you don't have any plan like this, you can add them, no problem. Okay, so I can do this into two. Not two, sorry. The same thing for the topsoil. And it will be multiplied by 0.15 in this case. Okay, so you can see it's mentioned here. Or it's mentioned for retaining. So they are showing that they will dispose the material of the bulk excavation and they will retain the material of the topsoil. So this could be the reason that they are not, doing it for both of them. Okay. So for example, if you have now this is an example for a trench foundation. Okay. So we are doing the excavation measurement for the trench, which is shown below. So the trench has a height of 1000, the depth of 1000 and the width of 600. Okay. I mentioned already that the trench means that it's a very narrow foundation which goes under the entire wall. Okay. So the only thing which you need here is length. Okay. The height is given, the width is given. The only thing which you need is length. Okay. Now here you can see that they did not mention the bulk excavation. Okay. So maybe they are doing they don't need the bulk excavation. After the topsoil removal, the ground is at the required level. So it's fine. And they feel that it's strong enough and you can just compact it and use it. So this can be done as well. Okay. So this is a very simple example. Okay. And for the excavation, so the length is 36 meters coming from the plan, 0.6 meters the depth and 1 meter the height. And the excavation amount will be this much and the disposal amount will be the same. So you can see it is bracketed. Okay, remember the bracketing. So it's very simple. Okay. Okay. So I was mentioning the blinding. So blinding, if you remember, comes under the footing, the main footing. Okay, and then you can see different types of concrete foundations here. And you can see the formwork over here as well. Okay. So then we have the concrete foundation. Okay, and it could be strip foundation or something else. A strip is same as trench. Strip and trench are the same. So we use a center line method for these types of foundations. If you have a strip foundation, trench foundation, we use a center line method to calculate the excavation and the concrete and everything. Okay, the width will be the full width of the trench, and thickness is as shown in the drawings. Okay, thickness meaning the height. This thing, this is called the thickness of the foundation. Okay, so don't be deceived by the word here. When you say thickness of the footing, we mean the height of the footing. There might be formwork requirements, okay, depending upon the type of construction method you are using, okay. And concrete foundations are usually have steel bars in them, obviously, and we have calculated the steel bars for this in the previous lectures as well. Even in the last lecture after the quiz, we did the calculation for the steel bars of the footing. So this is a separate item. So for concrete foundation, there could be 3 items. For concrete foundation, there could be 3 items in your bill of quantities. One for concrete, one for steel, one for formwork. Okay. So, and this depends upon what type of footing you are giving, what type of foundation you are giving, and what type of method you are using for the construction. Okay, so you can see that the footing goes in situ concrete works. By the way, we have discussed earlier that the concrete can be in situ or precast. Footings are not precast. Okay, footings are not precast. So they are always in situ. So you will always find them here. Okay, and you have to mention the description. You have to mention if you are using it in blinding or structure, and the foundation is here and so on and so forth. Okay. Then we have the hard core and the concrete ground slab. Okay. Hard core is the filling which you do to get up to the required level under the ground floor slab. Okay, so you have the reduced level, then you fill it to get it up to the required level where you will put the slab. Okay, so hardcore means that it should be strong material. You can see they are using aggregates here. See, okay, so it's strong solid aggregates. Okay, then over the aggregates they will put damp-proof membranes. Okay, damp-proof membranes which are measured in square meters. Okay, they are for the protection of water seeping from the top or from the ground. Okay, we want to protect the seepage of water from the ground to the slab, or the other way around in both cases, because the water is leaking from the house to the ground is also not good. If it keeps on leaking like this, it will damage the structure. It may cause the building to sink down as well, and have deformation and so on and so forth. And then you have the concrete ground slab itself. So you have the hardcore material, which is the filling under the slab. And then you have the damp-proof course, which is a membrane. It's like a cloth. Okay, if you have seen it in some construction projects. And then you have the slab itself. Slab is made up of concrete. It will have steel in it, or it may have steel in it. So concrete is cubic meters, and steel and formwork, as you have done previously. And damp-proof course or damp-proof membrane, not course. Damp-proof membrane is measured in square meters. As I said, it's like a cloth. So you just take the total plan area. Okay, and hardcore is filling. Okay, so filling, then like we had done filling earlier, so it will be measured in cubic meters. Okay, so yeah. You have the footing, you have the ground beam, you have the wall here. Okay, and this is the ground slab, and this is the hard core. Okay, so this goes up to the from the reduced level to the level of the slab. Okay, and over the slab you will this is a damp-proof membrane. Okay, and you put it over the slab and you put it up. In this case, they are saying they put it upside down. Okay, and then you have another damp proofing which is under the wall. So there are two types of damp proofings. One is for the slab and the other one is for the wall, under the wall. Okay, so uh, under the wall is not a membrane. Okay, it's a layer. Okay, so it's a material which you put under the wall. Okay, just above the beam, ground beam, or just above the footing foundation level under the wall. Okay, before you start the brickwork or the block work, you put this coating. Okay, this is damp proof coating, if I'm not wrong, DPC. Okay, so it's like a coating is a layer. Okay, membrane is like you lay out something. It's like a cloth. Okay, but the DPC is different. Okay, it's only under the wall. So we protect our slab as well as the wall from dampness and water using these membranes, membrane for the slab and coating or layer for the wall. Now you can see here they are using the wall which we typically use in Bahrain. We don't use this type of construction in Pakistan, by the way, for the walls, obviously, for the walls. I'm talking about the walls. So this is very much relevant to you guys. We have the external wall, the internal wall. Between them, we have the cavity. Okay, cavity wall. Okay, external, internal, sorry, external here, outside, on your left-hand side, internal on the right-hand side. Between them, we have cavity. Cavity means a spacing. Cavity means a spacing between the two layers, the two faces of the wall. Okay, and this cavity helps to maintain the temperature. It has to maintain the temperature. It gives you noise proofing and so on and so forth. It has many advantages. So they do it in Bahrain. I believe it's part of standards, EVA standard or something. So this is we have two faces of the wall. Between them, there's a gap, and the gap is called cavity. Okay, this is filling for the hardcore, the standard for filling of the hardcore. Okay, and it can be used for filling of any other type of material as well. The same standard can be used for filling any other type of material. Okay, and usually it is imported because you want strong material, as I showed you the aggregates. Okay, and these are things you need to mention. Okay, is it exceeding 550 millimeters? If it is exceeding 50 millimeters, is it exceeding 500 millimeters? And so on and so forth. You need to mention the thickness of this hardcore. Okay. Are you giving any cambers? Is it sloping? If it is sloping more than 15 degrees, less than 15 degrees. If you're going to dispose it off, or sorry, if you are going to import it from somewhere, from where it is coming and so on and so forth. So these things must be mentioned. Okay, this is the damp proofing membrane. Okay. Over 500 millimeter wide, like more than 500 millimeter wide, and it could be less than 500 millimeter wide. And this is the usual one, damp proofing membrane, and then we have the other ones as well. Okay, all of them are for damp proofing, for waterproofing. Okay, and it's driven under the ground floor slab. Okay, and as I mentioned, there's another one which is done under the wall, which is called as damp proof course. So it's a layer. Course means a layer. Okay, course means a layer. It's under and you will not see damp proof course here in this section. This section is for the groundwork. Okay, so you will see the damp proof course under the masonry section. Okay, so they are in different sections. The purpose is same, but the sections are different. Then we have the block work and the brickwork in the foundation. As I mentioned earlier, brickwork, foundation means here anything under the ground level. Anything under the ground level is foundation. Okay, so so it could be your wall could be made up of a brick or block of concrete, brick of clay made in or baked in oven, and it is measured in square meters along the center line. So again, we are using the center line. So we are using center line for as trenches foundation. We are using center line for wall block work as well. Okay, and it is measured from the top of DPC. It is measured from the top of concrete foundation to the top of damp proof course. Okay, the block work which is included in here. Okay, so I'm not talking about the entire wall. Remember, these slides are about substructure. So we are not talking about the entire wall. We are talking about the part of the wall which is up to the DPC, up to the ground level. After DPC, the ground level is finished. Okay, so up to there. Okay, so it's different from the rest of the structure. So brickwork, blockwork below DPC level is commonly specified to be in cement mortar. Okay, so we use different material there. And we have cement mortar, we have gauge mortar, different types of materials. Okay, and it must be mentioned what type of material you're going to use. If you are going to use different material for substructure and superstructure, you have to mention it in the description. Okay, and the other rules are the same. Okay, the other rules are the same. The rules which you follow for calculating wall material for superstructure will be followed for substructure as well. So most of the rules are same. So this is the masonry structure, the masonry section, number 14. And this one is for block work, brickwork. You have to mention the thickness. If you are giving hollow walls, then you have to mention it. If you are using any formwork, it depends. Then you have cavity. I mentioned the between the two walls, you have an opening or a gap, cavity. So forming of cavity will take separate rate. Okay, so forming of cavity is not the same like I will make two walls and cavity is done. No, you have to calculate the quantity of cavity separately according to NRM, what they're saying here. Because within the cavity, you have to provide ties and you have to maintain the width and so on. You may have to do formwork as well. There's dam proofing course, which is under the wall, and it is in section 14, not in the other section of groundwork, and it is measured linear. Okay, if the width is not exceeding 300 millimeters. Width of DPC is same as width of wall. Width of DPC is same as width of wall. Okay, so you need to mention it. And if it is less than 300 millimeters, we can just mention the length. And the length will be taken from center line. Length is center line. Okay, same as a wall. Okay, the number of layers and nature of bedding material have to be stated. Okay, so you have to mention what type of material you are using for DPC because there are different types of materials. And in how many layers you have to put it. So for example, your DPC is 200 millimeters. You want to put the entire 200 millimeters in one go, or will you make two layers of 100 millimeters? You have to mention that as well. And then there is no allowances made for the laps. Okay, what is a lap? It is a overlapping. So for example, your wall is, you have a very big structure. Okay, so you did half the wall today and you will start the next wall tomorrow. So you cannot leave a joint for anything. Keep it in mind. It's the same for concrete as well as same for everything. You cannot leave a joint or a gap between the work of one day and the work of the other day. So I finish here today at 2 meters. So tomorrow I will not start directly after 2 meters. I have to fill this gap. I have to make some joint between them, the old work and the new work. Okay, so if it is steel, if it is DPC, then you can do some overlapping between them and this will create a joint. For concrete, then we use some different methods. Okay, using steel or anything. Okay, so depending upon the type of material. But you, the contractor, according to NRM, contractor cannot quote extra money for this lap. And he's doing, oh, I will do lapping on 3-4 days. So I will have 2-3 meters of extra coarse layers. So give me extra money. He cannot claim that. Okay. So lapping is included. Overlapping of different days is included in the price which he is quoting initially. Okay. So the dam proof code, as I mentioned, less than 300 millimeters, more than 300 millimeters, less than 300 millimeters. You don't need the thickness, like you don't need to multiply the thickness. You can measure it in length. More than that, you have to mention it, and you have to mention the number of layers, the thickness, the composition, and mix of the material. Okay, because it could be one material, could be a mix of material. Okay, so this one. Okay, what am I looking at? Okay, so you have, it's the same plan which I showed you. Okay, internal dimensions are given. The wall is 277.5 millimeter thick, the wall. You can see it here in the section. The footing is 700 millimeters thick. The concrete is a concrete foundation, 20 kilonewton, no reinforcement. You can see the cavity over here. You can see the external wall. You can see the internal wall. Okay, this is the hard core. Sorry, this is the reduced level. The hard core. Then you have the concrete slab. Below the slab, you have the 1200 gauge polythene damp-proof membrane. Okay, under the concrete. Okay, so and then you have the two faces of the wall. Okay, the cavity is 75 millimeters. So total is 277.5 from this face to this face. Okay, and the cavity is 75 millimeters. Inside cavity, there's the insulation. Okay, of 50 millimeters. Okay, so it's not completely filled. It's not completely filled and it's not completely empty as well. Okay, so on this side, we are using concrete blocks, and here we are using half brick facings. Okay, so they break the brick and they put it here because of the thickness. The thickness is very small here. So total is 277.5, and then you, I don't know, the block is given somewhere. The block width not given. Okay, so you have the concrete footing, you have this is like the existing ground level. This is or the reduced level maybe. Okay, it's not mentioned. And what else? 150 millimeter is the thickness of the slab. Okay, what else can I tell you from here? Okay, so it's the hard core fill from here to the slab, up to the slab. Okay, from top of the footing up to the slab is the hard core fill. Okay, but it's done in two layers basically. One on the projection of the footing, the other one here. Okay. Now for the topsoil removal, we will take the extreme length. Okay. I believe this is done here. Okay. I'll stop here because we will be doing some calculations. Okay. But I've given you the concepts now. Okay. I believe doing the calculation, the class will be more beneficial for you guys, for me as well. You have any questions? Anybody has any questions? Just stay here. I will be doing the attendance. In the meanwhile, if you have any questions, let me know. Okay, everything good. I will stop the recording.